Hello, everybody, and welcome to the Let's Talk About Data show. We've got another great episode lined up for you today. We're going to be discussing Redshift. We've not had Redshift on this year, so we'll be talking about customer 360 analytics using Amazon's Redshift serverless multi-warehouse. So quite a mouthful, but we've got lots and lots of interesting content today. Some links to share with you. We've got a demo as well. But just before we get started, let's do some introductions. So I'm Tony Mullen, one of your regular show hosts. So it's great to be back on. I've not been here for a few weeks actually, so it's good to be back. And I've got Saman and Shrikant with us. So Saman, do you want to give us an introduction, little 101 on you?
Yeah, thank you so much, Tony. Thank you for having us today here. My name is Saman Irfan, and I work as a senior go-to-market specialist solutions architect here at AWS, focusing on analytics. I'm based in Berlin, Germany, and I am been with AWS for around 4 years now, and really excited to be part of this show and looking forward.
Excellent.
Hey Tony, thank you for
Hey,
having us
Shrikant.
here. I'm Shrikant Das. I'm a GTM specialist solution architect based out of Amsterdam. I work focused on analytics. I work with customers across Europe North, which includes the regions like the Baltics, Nordics, and the Benelux. It's almost 7 years in AWS, and it's a great place to work, I can say. Let's start.
So we got some experience here then. So I'm like 2.5 years in AWS, and Saman, you're 4 years, and Shrikant 7 years. Wow, good going. And we're
Before you
tuning in,
realize.
yeah, a little bit across Europe as well. So I'm Manchester. Shrikant, you was Amsterdam.
Yeah.
Saman, Berlin.
Yeah, Berlin. Yeah.
Nice. How's the weather for you guys there today?
Yeah,
So
it's a good.
we've got a little
It's
bit of
sunny
sun.
today.
Yeah,
It's
nice.
sunny today for a change, yeah.
Yeah, it was. Yeah, no, we've been like that in the UK. We've actually had some sun, which is great. So, do let us know in the chat as well. You know, pop in the chat where you're tuning in from today. Let us know what the weather's like. Let us know how your day's going. We've also got Lydia on chat support today. So, any of the questions we can't deal with, Lydia's going to be there like a superhero picking it up for us. And as I said, lots of links will be going in there today for you to take away. We also have our community page as well. So after the show, we'll be putting all of the links. Plus, there'll be a catch up of the show going on to our community page. So we'll share the link for that in a little while as well. It also has our past shows on there. So feel free to go and take a look at that. So we've got a few people saying hello here. So we've got Eerie Edits. Hi, everyone. Hi. I'd say Lydia's going to be doing our show support today. And watching from Los Angeles, nice, not jealous.
Nice.
And we've got Robert Tables from Indianapolis, and the weather is amazing. The Pacers are going to the NBA championship. So, yeah, I'm not really, don't really watch NBA that much. How about you guys?
No.
Watch NBA? No. Soccer for me, or football. Data Whisperer, hi, one of our regular viewers, and yeah, tuning in from UK. And we've also got, is that Hale? Yeah, Hale 24, and tuning from Orlando, Florida. Nice. God, we got some nice places people tuning in from. And Evelyn, hi Evelyn, how you doing? So right, let's get going because we've got lots and lots of content to go through today. So let's get started. So I guess for people who are new to Redshift, let's first talk a little bit about Redshift. Just give us a little bit of a kind of 101 on Redshift.
Yeah, maybe I can talk about it. So basically, Amazon Redshift is our cloud data warehouse offering. It's a service, and it's being built to process petabyte scale of the data for analytics and business intelligence use cases. So for the customers who have like SQL analytics and business intelligence and these kind of use cases where they want to drive insights from the data, Redshift is like a solution for them. And it's like it has two types of offering. It has the provision clusters offering, and it also support serverless. So depending on the customer use case, you can go with either provisioned or serverless. But in a nutshell, it's like from AWS side, it's a data warehouse offering available in the cloud.
Nice one. And what's the difference for that as well? Just kind of for newbies out there who potentially don't know the differences. Just give us a little overview on that.
So when we
Between,
talk about So when we talk about provision and serverless, so the basic difference is when you are going for a provision, we need to define the number of nodes and the type of nodes, like right size the instances. And this serverless is pay as you go. However, we have some commitment based pricing recently launched, but the thing with serverless is you do not worry about having how many number of nodes you need to right size. You just run your query, it runs for a certain time, and you pay for the usage. So this is the basic difference. When you look at it at a use case perspective, so let's say you have a use case which says 24/7 workload, like a ETL batch processes running 24/7 kind of workload. So probably provision would be the right choice, recommended choice here. And if you're going for use cases like there is spike in workload or off-peak hours or a 9 to 5 kind of job, probably Redshift serverless would be more beneficial and cost effective for you.
Yeah, and what do you see customers using? You see a mix of the two from customers' use cases?
Yes, definitely. So based on the use cases, of course, customer prefer mix of the two, like a hybrid kind of model, or they try to go in full serverless if their use case permits it. But it's not a destined or a custom thing which they need to use. It doesn't come like a book. But hybrid would be the right choice if you know there are certain use cases where you want to span across different workloads.
Yeah, especially I would like to add here. So in the data warehousing paradigm, it's not like a business intelligence use case. There are multiple kind of use cases, ad hoc analytics, let's say data science use cases, building up, running on the data warehousing solutions. So the topic that we are having here today is basically the right fit for having a hybrid kind of a model. So you can have a mix of provision and serverless depending on your use case and your workload requirement on, let's say, how intense is the workload, what's the resource utilization, how much duration, and these kind of things then comes into picture in deciding, okay, what should be my right configuration for the target use case that we run on our data warehousing solution.
And that makes sense. That's a good point. That so it's not like a one fits all. It's like you say, especially the names in the title, multi warehouse. So yeah, that's cool. That makes sense. So what are some of the common challenges organizations are facing when it comes to dealing with data across multiple warehouses? What are you seeing from customers?
I'm not sure if it's. I think I'm back. I'm not sure if it was internet issue at my end or yours end, but there was.
I'm not too sure. Can you hear me? Okay.
Yeah.
Can you hear me? Okay, Shrikant? Yeah.
Yeah.
Yeah. Maybe it's Saman's got some networking issues. Yeah, it looks like Saman's got some networking issues. So, I guess there's some background noise going on there. So let me just see if we can just mute. There we go. Just remove Sam out, and we'll add it back in a minute. The joys of live streaming. So you can see we are live. This is not a video. So anyway, back to what we were talking about. So what are the common challenges? What we're seeing then with customers facing, data across multiple warehouses and Shrikant?
So major challenges what we have observed across different customers is basically there are data silos. So customer wants to run a use case, and with the rise of generative AI, so you want to have all your data at one place, but data comes in silos. You have a streaming data at a place, and then you have different data from IoT devices or operational data store. Everything varied across your operational data stores and S3 data lake or any other sources. So if you have data silos, it's really important to break the barriers, break this thin line between the data services. So that's one of the major problems or challenges I have seen across customers. And there are other challenges as well. I would like to know, Someone, do you want to add something on that?
Yeah, sorry, I had some internet glitches.
We got you back. Yes.
Finally, okay. Yeah, sorry about that. So yes, so regarding the challenges with the like what we see nowadays, that like most of the customers, the one of the biggest challenge that organizations are facing is the data silos. So once the data is like in the different systems, and which then makes it difficult to drive the insights, like combining the data. And how they do it is that they had to, let's say if they have to build some kind of a use case and find some insight, they have to perform the data replication. So they have to replicate the data from multiple systems into one target system, and then based on that, they have to, let's say, build their business intelligence applications and run the queries and these kind of use cases. So, which means that a lot of effort needs to be done, and which building up of the ETL pipelines and these kind of a things. So this is the like common challenge, data inconsistency challenge comes into picture, and these kind of a things is the what organization face.
Yeah, that makes sense. Yeah. So one thing we've not talked about is customer 360 analytics. So we have that in our title, don't we? We're talking about, customer 360 analytics using Amazon's Redshift. What is customer 360 analytics for people who don't know?
Yeah, so if you look at use cases like advanced personalization in e-commerce or churn prediction, so this kind of use cases requires data from multiple sources. So if you have customer data coming in from different systems, it can be coming in from a ERP system, a CRM system, or mobile apps, or web-based browser. So you have data coming in from different system. You want to have a proper prediction, churn prediction. If you're doing, you want to have a proper prediction. Or if you want to get some personalized recommendation, I can browse in through my mobile, I can browse in through the web browser. How do you get the data from both the platforms or multiple platforms a single customer is using and recommend the right choice to that customers? Like if you look at the Amazon retail, hey, would you like to buy this thing? So this kind of use case requires data to be at a same platform, like a unified platform, or having data accessible to the users who are running these churn models or prediction models across different platforms seamlessly. So this is a use case which actually helps us in achieving this. If you look at it, Redshift has certain features which allows you to do this customer 360 analysis.
Yeah, that makes sense. Yeah, and data, the way the world is at the moment, there's more and more data, and it's coming from all different locations, like you're saying. So really, it's that holistic view of all your data in kind of for your organization, be that where it is. Is that correct? Yeah, cool.
Yes.
And I guess from a Redshift perspective, like Redshift is a data warehouse, but all the data doesn't have to be stored in Redshift. Is that correct? You don't need to store everything inside of one data warehouse. And that's what we're saying here with multi warehouse. Is that correct?
So regarding the Redshift, yes. So basically, Redshift has the capability to query the data lakes, and so you do not need to store everything inside Redshift. That's the idea. You just bring in the data which you need for the business intelligence use cases, and maybe kind of like a hot data. So you bring the hot data into Redshift and keep the cold data in S3 data lake, and based on that, you can, when required, you can use some of the additional features of Amazon Redshift. For example, Redshift Spectrum to query the data that sits in the data lake and combine the data, hot and cold data, to then in the end drive the insights. So yes, not all data needs to be inside Redshift all the time.
Yeah, cool. So so when you're talking about Redshift data sharing, so how does that actually work? When you're talking about this in the multi-warehouse, because it sounds quite complex, is it?
So no, it's not that complex. So basically, there's a Redshift architecture which enables this data sharing kind of a whole, which enables the data sharing, which is based on the separation of storage and compute. So in the Redshift, especially in the RA3 node types, okay, so if you look at, if the audience that's listening, if you go and Google the RA3 node type as well as Redshift serverless, so the architectural by design, they are there's a separation of storage and compute. Okay, so the data sharing works on the storage level. And if you share my screen, Tony, I can quickly show how does, yeah, it's better as pictures speak louder. So that's why I
They
wanted
do speak
to.
lots of words. Yeah, I agree
Yes,
with that. Yeah.
exactly. So if you look at the Redshift data sharing whole, like from the architectural point of view, so with the data sharing, you can have a combination of the provision and serverless endpoint. As I mentioned initially, you don't need to fit in everything into one cluster, and you can break down the clusters into based on the use case, as well as each team can have their own cluster. Okay, so this is something that it enables it. From the little bit technical point of view, this data sharing is like it's an instance. So the data resides in one cluster, and then an instant, secure, and transactionally consistent and live access of the data from the other clusters is given. So it enables a lot of different kind of a use cases. So for example, workload isolation, chargeback models, and these kind of a different use cases. So you can read and write. You can read and write to like from the different data warehouses and enable this data sharing with Amazon Redshift data sharing.
Cool. And how do they talk to one another then? The different, is it just like a database link, or is it some form of federated query? You know, the different Redshift clusters.
No. So there's no database link. Behind the scenes, basically, the computes are separated, but the data sharing happens on the storage layer.
Okay.
So it's not database link. There is no federation, but it's like the storage is being shared between the different compute endpoints, and then they can query the same storage layer.
That's so nice. That sounds so it should be nice and quick as well. We've got a few questions there as well, which I'd like to share up. So let me just get these questions up. So Data Whisperer, would I experience latency when data is not stored in Redshift? So I'm assuming this is going back to when we talked about the data in S3, so the Redshift spectrum.
So no. So the thing with Redshift is it has storage and compute isolated, like someone explained. So you can have data stored in RMS, which is Redshift managed storage, which is in return isolated as well, or you can have the data stored in S3 data lake. When you want to use this data using Redshift spectrum feature, you can query this data without the need of copying or moving the data. There won't be a latency because of course you need to understand the data sets right there, and you need to query the data whether it is in RMS or S3. The compute you use provides you the SLA, so there won't be any latency.
I presume it won't be as quick though, will it? If the data is stored in Redshift on disk versus a Redshift spectrum query, would you expect to see a quicker speed and query back? Is that what I think the person
yeah,
was
so when we talk about quick, we need to understand the SLA over here. If the data volume is very huge and the partitions in S3, let's say the data is not designed properly, the partitions are not designed properly in S3, it might add certain latency. So we need to follow the best practices. And on top of that, yes, definitely, that's the reason we go for a cold and hot data tiering. If you want the data to be accessed very quick, you can use RMS. If you are okay with a few seconds latency, it won't be a huge latency, but a few second latency, you can go for S3. But the catch here is, if you are not expecting latency on both sides, probably you will need to put in more compute. So that's a trade-off you need to do.
Yeah, it feels like it's a whole new show in its own right, that talking about partitioning correctly in S3 and, you know, doing your partitions or how you would segment your data out in Redshift. So yeah, maybe one for the future. That it sounds quite an interesting show, that. So also got another question here from Data Whisperer. If I break my cluster into different warehouses, would that added maintenance overhead? So you get a maintenance overhead with having different warehouse clusters?
So maybe I can answer this question. So yes, it will add a little bit of maintenance overhead, but the benefit that you will get based on the workload isolation will be much more than basically thinking about the maintenance overhead. So we have a lot of customers who are getting a lot of benefits from this data sharing and isolating the workload, splitting up the workload, and which then means that the benefits is more than the maintenance overhead in the end.
Makes sense. And we've also got another one as well. Comparing managing single clusters versus multi-cluster. Yeah. So I presume that's the same question. So
Yes, it's the same question.
yeah, cool. So we've got a demo now. So let's go to the demo bit. So we've got a demo on Redshift serverless multi-warehouse and how that works. So Shrikant's going to do a demo for us. So let us know when you're good to go, Shrikant, and we can share your screen.
Yeah, we're good to go.
Cool.
So do
I
you
do
see
like a live. Is this a live demo as well? I believe it is, Shrikant.
Yes, it is a live demo. I'm going to do it. I hope it
Nothing
doesn't
could
fail.
go wrong. So,
Yeah. So do you see the Redshift console screen?
yes.
Yeah.
Is it worth showing as well? Because I know I've had a little play with Redshift. You've got the two screens, haven't you? You've got a dedicated and serverless. Is it worth just where you can click on the
Yeah,
side?
definitely.
Yeah. It's
So
worth showing people that.
yeah, when you go to the AWS console, you can just type in Redshift. I'll start from scratch for you.
Yeah.
And if you click on Redshift, it opens up something like this. So you have dashboards like serverless dashboard, and then you have provision dashboard. If you click on this, it opens up a provision dashboard. So for this demo, I'm going for serverless dashboard because I have created two serverless instances for this demo. So this is how the console looks like. So for now, for this demo, I have created two serverless warehouses. One is sales account by the name of sales account demo, and the other one is customer account demo. So I have created these two serverless endpoints just to demonstrate how you can enable the data sharing feature easily with clicks of buttons. Of course, you have data security and governance in place, but I'll try to keep it simple for everyone's understanding. And once you create this, you can simply click on this. This opens up the namespace configuration. So to give you an idea, namespace is basically the storage space. So where you have the metadata, the storage, and the assets created like tables, views, etc. So this is a namespace, and once you reach the namespace, it is associated with something called as a work group, which provides the compute. So so now here, if you want to query the data, simply click on query data. It opens up the query editor version 2. So this is the Redshift query editor. The data tree, you can see the databases you have access to. So let me go to the customer account. So this is the customer databases, and there'll be two separate databases in the data tree. One is for the external databases, and one is for the Redshift managed storage native databases. So anything you create in an RMS, you can see it over here, and anything external like a data share from another Redshift cluster or external table from coming in from your data lake, you can see it here. So for this demo, what I have done in the dev database, I have created a table, the customer table in the public schema. So if you want to see the table, you can simply click and go to the table. So this customer table, I've loaded with some mock-up data. Let me reconnect it. So to connect, it is simple. Good that it required me to reconnect. So you can provide your federated user, secret manager, and username password. For this demo, I have created with a username and password. So once you connect to the database, and you can simply run this query. To run this query, make sure you select the right database here, right endpoint here, and the database over here, and run the query. So ideally, we do not recommend to run select star, but I did because we have a limit 100 enabled over here. So I'm not scanning the entire table, but you can see it has some data. And then for this demo purpose, I have just kept the customer data in the customer endpoint, and the other warehouse which I have created for the sales, I have added two data there, the products and the sales data. If I go to the schema, you can see the two tables over here.
And these tables, Shrikant, these tables are on the Redshift cluster, not on S3 buckets. Is that correct? They're on Redshift
Yes.
storage. Yeah.
Yes, these are
We've got a
all
quick,
in the Redshift storage.
yeah, we got a quick question from, so Redshift stores data in tables or some other format. So it's kind of linked to it. In this case, this is a table on the actual Redshift cluster, but is there kind of other formats you can store the data in S3?
In Redshift, when you store the data, it's in Redshift proprietary data store, which is the RMS. And if you want to store it in S3, yes, of course, S3 supports open table formats. Like if you are storing data in Parquet format in S3, you can read that using the spectrum. You can have data in Iceberg format, CSV, and there is a list of formats. What we can do is probably we'll share a link in the chat, which shows the supported formats for S3.
Yeah, great.
Maybe I'll just simply add to that. So Redshift supports structured as well as semi-structured and unstructured data as well. So for the structured data, definitely you can have the table and all the data types that supports the structured format, but it also has the ability to upload. You can upload the unstructured and semi-structured data in the super data type. So you can have the data in JSON, struct format, and different other formats, and you can simply load that into the super data type. And then you can use party SQL, which is an extension of SQL to query that data. So I mean, there's a lot of not just structured but semi-structured and unstructured data you can load into Redshift and query.
Yeah, and it's worth explaining that and showing that to people as well. Yeah, because I think that's really good. It makes like this one we're using is structured tables inside of Redshift.
Yes.
And somebody's enjoying, so Muru's enjoying learning Redshift on the stream, which is great. That's what we're here for. We're here to teach and, well, show people the things you can do with the products. So back to you, Shrikant. Sorry about pausing you then halfway through, but I thought these questions were pretty poignant with what you were doing.
No, these are totally helpful because we can relate to the audience better. So getting back to the data, so here for the demo, I have taken structured data, but of course you might have events data coming in from your web browser. So you have JSON data coming in, you can store it in super and use the partiQL syntax to retrieve the data. So that is also possible with Redshift. But for now, if I go back to the sales database, let me connect to the sales. And then so here I have loaded the data. So I've loaded some mock-up product data just to demonstrate you. So again, the server is closed. It's not nothing which happens multiple times, but yeah, this is the one we connected for the first time during the demo. So yeah, this is what happens. So the best part is, yes, of course, you can put in connection timeout settings and everything for your security purposes so that nobody runs a session and leaves you hanging and hogs the memory from your cluster. So I got timed out because I have connected some time back. Going back to this, I select sales dev and I just to show you certain data, I am running this table. So it has some product data, same with the sales data. The beauty of this query editor is it shouldn't happen here. So these are isolated sessions. Let me go back here and then run it. So the beauty of the query editor is basically it provides you certain flexibility, like I showed you about the limit 100, and then you can connect to multiple warehouse and run the query. Like here we are running from the customer warehouse and from product warehouse, so sales has certain data. So now we have the data. What we need to do, we need to demonstrate you how data sharing works. So going back to the use case, if you remember, we talked about customer 360 data coming in from other systems, CRM, web browser, multiple teams. So in this case, let's take an example. You have sales account where they have their own database and they store sales and products data. And then you have a customer account where you have customer database and you want to use both the data from both the systems and run certain business queries. We'll talk about the business queries later on. How do you do that without building ETL pipeline or building a flow to copy the data, making redundant copies? So that's when Redshift data sharing comes into the picture.
Excellent. Let's see it in action.
Yeah. So Going back to the console again, I go back to the Redshift console. Now here the purpose is I'm going to share the customer data with the people in the sales team. So sales account needs access to this customer data. I'll select customer data, and then there is an option for data shares. You connect to your database, use a recent connection, or you can connect using new connection. So as I have connected, I connect to database, and once you connect to the database, you can see the data shares already created here. I created for this demo, and if you want to create one more, just simply click on create data share. It opens up this particular window. Let me name it demo data share. Database name, for now I have only one database in the endpoint, so I will specify it as dev. Publicly accessible, you can turn in and turn off, turn on and turn off. Basically I'll turn it on for now. Scope permission, so permissions are important. However, you can have a centralized permission using AWS Lake Formation, but for now this demo I'm showing you how simply you can manage the permission over here as well. So grant scope permission. So for this purpose, you have multiple options. I will keep the basic permission like usage, select and execute. On this particular database, you can see what are the permissions I have granted.
So you can break it right down to select as well, then, can't you? So they can't actually do anything on that. You could just be querying from that cluster. That's quite nice.
Yes. So so data share also allows you to write data to the source, right? So
Yeah,
in that
see
case,
the different bits you had. Yeah, if you go back to those grants, there's a load of different grants, weren't there yet? So
yeah. So so you need to be very vigilant on this, because you do not want someone to steal your customer data or write into a or delete the data,
or
which of
delete it.
course
Yeah, not what you want.
which of course won't happen. But yeah, it's better to have it checked in the beginning.
Yeah.
Going back to the direct permission, grant direct permission, and then you can select whether you want to select certain tables, views, or user defined functions. I'll go for the schema directly to keep it simple. I'm just selecting the schema and I'm granting permissions over here. At this point, you need to add namespace to the data share. Like I said, your namespace is basically has all the storage like data assets, a data table, views, and etc. So here I'm selecting which namespace needs access to this particular share. So I want to grant access to sales account, and you can grant access to multiple through the checkbox. I'll keep sales account. Beauty is it's not only in the same AWS account. If you have different AWS account, you can add your account ID and add AWS accounts as well. So as I'm doing in the same account, I'll keep it unchecked and create.
So you can go across multiple accounts, then is that correct? Is it multiple accounts in the same region, or can you go multiple accounts in different regions as well?
So yes, it is possible cross account and cross region, but there are certain limitations to it in the cross region. Like we haven't released certain features in all the regions which are new and coming up, but it is possible in cross account and cross region.
That's great.
So you see how easily and seamlessly the data share is created.
Yeah.
If you want to verify, you can simply come here and see, yeah, the data share is created. Now, as a consumer, this is a producer account. As a consumer, how do you make sure the data you have access to has been connected to your system? So what you do, you go back to the console again. So let's say I'm from sales account now. I'll click on sales. I'll check on the data shares, the data which has been shared with me, I can see over here. So I'll just connect using recent connection. So this is where the data shares pop up. So this is the one we created right now, and simply click on create database from data share. This is important. Why? Because yeah, so this is let me do the case sensitivity thing. Yeah. So this is important. Why? Because you have shared the data, but you need to create a metadata like an external database which points to the data. It's not something you are replicating, but it is rather creating a metadata which points to the data so that you can access the data if you want to read the data. So coming back to this, I have given this name as a demo data and click on create. That's it. The
And
data
then I guess when you see that inside your database, you'll see it as an external database when you have the metadata in there, which I guess we'll be able to see now. Is that correct?
Yes, that is correct. That is spot on. So if you go back to the sales account, I will just refresh it, and see, I do not get the connection issues now because I've already connected. And now I go back to this. This is the one I created, the demo data, if you remember. I click on this, I open it, public, and there we go. We have the two tables which we created there, the supplier and the customer table. So if you remember, I shared the public schema. So it basically shared the tables in that schema. So I had two tables, both of them are shared. However, you can restrict what to share and what not to share. So we can see this table over here. Now let's take an example how this is helping. This is an use case I tried to create. So what if you have a business users who wants to understand the total sales for product per customer, or product and customer, or however you can say. So you need to join this data, product data and customer data and sales data all together. However, the catch here is product and sales is in your database, but customer is coming from an external database. That's when the data shares come into picture. How do you read this data? So if you notice the sales data and product data, I'm reading it as it is, like it's coming in from my own database.
Yeah.
So I can simply type in the schema name and the table name. So same with the product data, right? This is where the catch is. So the table we created, the database we created for the external data share is demo data. If you go back to the tree window, and of course we need to verify. So this is the demo data. What you need to do is simply need to write in demo data and then the public, which is the schema name where we have the data table created. And this is the data coming in from the consumer cluster.
Mm-hmm.
So if you notice, I haven't created or loaded this table altogether in my current system. It is just getting shared live from the source. And let's see if it runs. As this was an isolated session, that's my mistake. I could have run it in the same one. So let me run it over here.
Yeah, just while you're running that, we got a few people saying hello. Hello, Victor. Good to see you. And same with Yashvant. Good to see you too. And we'll pick up this question. We've got a question here actually. Let's do it now while we're having a halfway just in between. So yeah. What is that FX function procedures part in Redshift, and what can we do with
that? What function is it?
FX functions procedure. Are you aware of that?
Yeah, someone you want to take it?
Yes. Maybe I think he or she is referring to us like functions and procedures in Redshift. So like Redshift supports functions as well as you can create stored procedures. This is what I'm understanding. I'm not sure if my understanding is correct. I can explain what does functions and procedures does in Redshift if this is the exact ask.
Yeah, I think that'd be good. Just give us give a little 101 on it. And we can also get Lydia to share something in the chat as well with it. So just a very quick brief, what is, procedures and functions. Yeah.
Yes. So procedure is something, for example, if you have to do some kind of an ETL kind of a processing, like you load the data and then you have to perform some transformation, some data modification, cleansing. So this is what procedure comes into the picture. Function is something you can simply say it's a function where you pass on your data value and you want to it's like a code that you create inside Redshift. And if you have to do some processing, for example, let's say you want to convert integer into some different data type, or maybe do some kind of these kind of a processing. So this is where functions comes into picture. So this is the difference between both the functions and procedure. If Lydia can share some documentation, so that might be helpful.
Yeah, that'd be great. Thanks for that. Shrikant, back to you. It looks like you got the query going. So just a little recap on it. We're going across databases here, aren't we, this query, and we're joining the data?
Yes. Right. So I'm running this to find the total sales for product and customers. and I'm joining in data in the Redshift sales table, which is residing in the sales Redshift cluster. So these two tables, and then the join with the customer data, which is coming in from another data warehouse owned by the customer team and shared through the data share Redshift data share feature. Once I run this query, if you notice, I get this results. So it is seamlessly able to read this data without making the redundant copy of data. And the most important thing, let's say the customer team, the team managing the customer data decides to update the data. So while they're updating the data is live. I can see the data. So they updated, the commit is made, and when I see the data, I see the fresh data. I do not need to wait for a ETL job to copy the data and to my cluster before I read the data, right? So this is the most important thing of data sharing. However, what I showed you is only on a read basis. So if I go back and stitch it to the customer 360 analysis, you might have a customer 360 database where you want to write data into that customer 360 table from multiple data warehouse. It can be a sales team writing to the same table and product team writing to the same table. So it also, so Redshift data share also provides you write access to the data warehouse. Not only read, we have recently launched the write access, which is really helpful in this kind of use cases.
Yeah, that makes sense. And I'm assuming as well that same sort of query you're doing, if they had some data stored, let's say that data, the public customer data was stored on S3, you'd be doing the same sort of process. Can you join data what's in S3 with the Redshift data?
Yeah, of course. So if you have data in S3 data catalog, let's say, so if you have it in S3, you can simply see something like this AWS data catalog, which will be auto onboarded. And because it has certain access issues for this demo, so it will be visible similarly, and then you can simply see the Redshift, Spectrum tables over here. So the data will be underlying in S3, and you can same way join RMS tables with your Spectrum tables or with your data share tables and produce the output.
Yeah, so you've got such flexibility then, haven't you, with this multi-warehouse strategy as well as data stored in S3. You are talking about that true 360 analytics approach.
Yes.
It looks really, really, really neat.
And to add to that, the flexibility is not only with the data coming in from the lake house, data warehouse, or the data lake. Let's say you have data coming in from streaming systems like Amazon Kinesis data streams or Amazon Managed Service for Kafka. You can plug in that data, like you can use Redshift streaming ingestion feature to get this data on your Redshift storage and query this data as well. If you have multiple systems like having a Aurora or a RDS, you can use the zero ETL to get the data, or federated query to query the data in place. So basically, when we talk about breaking the data silos, Redshift provides you features to access all this data for varied use case at a single place.
Yeah, you really are breaking down those silos with it. Yeah, it looks really interesting. Good stuff. Is that everything with the demo? Is there anything else you want to share or show us with the demo?
So this is everything with the demo, but maybe as we are talking about generative AI, I would like to show so Amazon Q generative SQL for Redshift, which is also integrated with the query editor. So basically, you type in your question or a prompt in a natural language. It tries to scan in your metadata and produce some results. So for example, I do not have much tables here, but let me.
Could you try and do that query you just did? So I don't know, 10 sales across them two things.
So I'm trying to do that live, but
let's do it. Come on. This is really neat though. If this, Q is great. I use it all the time, for creating bits of SQL for me. It's like Q developer command line. I don't know if anybody's used that out there. If you've used it, do pop in the chat. I think it's amazing. Yeah.
So usually this works, but seems like there is some because this is the demo account and some restrictions. So hence this didn't work. But usually this works pretty well and seamlessly. And how it helps the customers is basically. Let me see if it works.
It's live demos, Shrikant. We always get some glitches. It's the joys of doing a live demo, isn't it?
Yeah, definitely. If it doesn't fail, then it is not live.
Yeah, exactly. Yeah,
Yeah.
it really
Yeah,
So
but,
is.
yeah, but very good, especially the generative SQL, especially for the personas who are not very good in the SQL, like these things, and they can just simply use the natural language to produce the query, and what if it needs some kind of a tweaking, they can then do, and I mean, it can really accelerate their work.
yeah.
Yeah, definitely
So
can
if
make
you
if it can make
observe,
your life easier. So why not use it?
yeah,
Yeah.
right. So if you observe, this is what it did. It can write queries with joins and everything, but the reason being it is not working perfectly because I do not have much metadata and things, but still it was able to find, okay, because I just specified top 10 products, so it was
Yeah,
able to find,
got it.
hey, I have a product table and probably these two columns would be more beneficial, and then top 10 limited. So it actually tries to reduce your query authoring time, and it is conversational. If you
So if we
not,
try and run that, will that run now? So if we give it a go, see if that
yeah,
runs.
simply you can
Would
copy
be that
and
over.
then you can copy to clipboard and run it. Let me run it. So yeah,
Got
like
all
I
the
said,
yeah,
because it is a
the
demo
metadata.
environment, yeah,
Now,
it
maybe I
happens.
can add to it. Maybe I can add to it. Seems like Shrikant, the cluster is pretty fresh created, and this is basically behind the scenes. It runs machine learning behind the scenes, and it learns through the period of time. So
Yeah,
if we have a very less, pretty fresh, because this cluster was, I think, just created for the purpose of the demo. So it takes time to train itself, and over the period of time, it learns the metadata and all the information, and try to then generates the correct queries. It learns from the history as well, so all the kind of history information that we have in the system tables, and these kind of a things. But seems like
Yeah,
some other problem here.
I
yeah.
Uh,
think I
So
think we've hit the demo. The demo gremlins have come in and scuppered our
yeah,
demo here. So I mean,
but
this was an added extra one to do,
yeah,
wasn't it? But
sure.
it'd be useful
but
if
I wish I could have shared the thing. It is conversational actually, because
yeah,
when I type in I want to change the column name, it doesn't work. It actually fixes the query and sends it to me, but something is wrong with the demo. Yeah.
yeah.
But it works seamlessly when you do not have a fresh cluster, and it takes time, like someone explains you.
Yeah, I guess most people are now using generative AI tools. So for me, the benefit of this is it's actually there in the browser with you, isn't it? I'd imagine the future will be that you maybe will be able to do it in the command prompt. Like you don't actually need to bring Q developer up. You could do it in here, with some form of a slash, Q or whatever, and it will write it for you because it's just about making your life easier, isn't it? Which I think we're all up for that. I know I am. It's anything what can make my life easier. I'm is definitely a big plus for me. That was a really great demo. That thanks for that, Shrikant.
Thank you.
It was great. So we still got a bit of time left. So what are we on? We've still got like 13 minutes left. So we've got some other nice questions to go through here as well. Um, so what are the typical use cases you're seeing with customers using things like data mesh and hub? How are you seeing people share data? This is one mechanism.
Yes, yes. So basically, the customers that we work with, like let's say 90% of customers, there are some of the typical use cases that we see. The first one is the workload isolation kind of a use case. So if you share my screen, I actually have some very good presentation to show. If you can just quickly share it, Tony.
Yeah, there
Yes.
we
So if you see on the right-hand side, this is what a typical workload isolation use case looks like. It also enables like a hub and spoke kind of an architecture where you have an ETL cluster, a big ETL cluster for processing all the kind of your ETL processing. It can be nightly batch jobs, it can be streaming ingestion, so on and so forth. We have even the possibility to break down the ETL cluster, like for example, with the data sharing for write capability. But let's imagine we have one ETL cluster in here, and then we can have a purpose built Redshift clusters can be provisioned, can be serverless as a consumer. So we have a producer, and then we have a separate consumer for ad hoc queries. This can be a Redshift serverless endpoint. Then we can have a dashboarding, a Redshift cluster can be provisioned or serverless depending on the use case. We can have a consumer, let's say, data science cluster. So this is like a typical hub and spoke kind of an architecture that is being used in most of the customer. The other very good architecture is kind of a cross-group collaboration kind of a use case. So where we have a different teams and each team wants to have a separate Redshift endpoint based on their workload requirements, based on the usage requirements, and also they want to pay for their own resources utilization. So let's say we have a finance team, we have sales team, marketing team. Sorry, let me just go back just a moment.
Just while you're doing that, I will. Lydia shared procedure versus functions as well, which is great. Cheers,
Yes,
Lydia.
yes. So, yes, yes. So this is again a one very common kind of a data mesh kind of an architecture where each team have their own Redshift endpoint and they can share the data with each other in a bi-directional manner. And this basically enables a customer 360 kind of a use case. So let's say if the finance team needs the data from the sales team, so sales team simply create a data share and share the data with the finance team based on the requirements, whatever data is needed, and then the finance team can drive the insight. So this is what a typical patterns that we see with customers. There are other use cases as well. For example, deliver data as a service, share data between different environments, but these are a little bit less common. These two patterns are something that we see with most of the customers who are implementing the data sharing architecture.
Yeah, that makes sense. Thanks for that. Let's share. I've got a couple of more questions here, actually. So Lydia's has also shared hands-on learning as well, specific multi-warehouse. So, do take that, give that a look. And Data Whisperer, would the Gen AI help her work across clusters, or is it isolated in a single cluster? I think this was back to when we were using the Q developer.
Yes, yes. Maybe I can answer it. So basically, right now with the current capability, it tries to get the metadata of the shared, like the data shared database as well, but it's not mature. And so you can say it's not available at the moment. So the generative AI has more insights into what's in a single cluster. So this is something that, but yeah, as the product gets more mature, this might be added in the future.
Develop over time. I guess if people are using it as well, a bit like any of the things we do with our products, if you're using the product and you see something what's not basically something missing from the product, do reach out to your account team and we can raise product feature requests on your behalf to try and get that added into the product. That's how we add capabilities into the products at Amazon. So we've got one from Yashvant. So yes, we have to train our chat model. We're better promoting and defining the column tables, information's correctly, as per my R&D on working with Gen AI and refactoring code. So train chat like child. Yeah, definitely. Yeah, it's training those models. So let's share that so we get our nice pretty faces back on the screen. So let's talk a little bit about cost optimization, because cost is always a key one. How does cost optimization work in multi-warehouse setups?
So if you look at this perspective, cost is the most important thing. We need to take care of it. Now, how we deal with it? First thing, like I showed you, I'm not copying or moving the data. I'm reducing the storage cost here, redundant storage cost. Second thing, when we talk about workload isolation, like the hub and spoke model, which someone explained. So if you look at that, you might have ETL workload, you might have BI workload. ETL workload needs heavy compute. However, BI workload needs light compute. I'm giving some hypothecation, like let's assume your BI is lightweight and ADOCs are lightweight and ETL is heavy. But if you have a monolithic cluster, a single cluster to do all the workload, you are not right sizing it. You are probably either you will undersize it or oversize it, because you need to make sure the ETL workload performs. However, the BI workload is performing at a higher compute when it doesn't need. Isolating them will help you with the cost optimization and scale independently. So probably BI workload is fine enough for 2 nodes. I'm giving you a number and ETL needs 4 nodes. So you have 4 nodes and 2 nodes separately. You pay less for the BI and more for the ETL if you compare this way. and you scale independently. If your BI users keep on growing and ETL user do not, probably you just need to scale the BI users. So this helps you in the cost optimization. And the most important thing, like we already talked about, the chargeback model. So I am storing the data, I'm having my own cluster. Then there are users from other teams who want to use my data. Like the sales team wants to use customer data. Why should the sales team, customer team pay for the sales data? So they can have their own compute. They pay for the compute separately, and I just share the data with them. Anyway, I'm paying for the storage. So they can have a chargeback model here, like separate team paying for the compute separately. So these are various use cases and ways you can go for cost optimization.
Yeah, so you've got quite a bit of flexibility there, haven't you? Yeah, that's the key form for it. So I'm just looking at time. We are running very short on time now. So I can see Lydia posting some docs in there now. So I think we'll take. I reckon we've got. Let's see if we've got any questions in here which we can share. I'm just trying to see how much time we've got. We've only got 4 minutes, so I think we're going to have to wrap up. I think for today. But what I would love to do, I think we need to get you on for another show and do more of like a performance or data modeling, with Redshift, because I think we kind of scratched it a little bit there with the topic we're doing here, and there was some other nice questions we had. So I think we will have to look to get you on for another slot later in the year. Would be really good.
Yeah, before we close, Tony, very important, especially for the customers who we are doing a lot of talking, but for the customers who really want to get started on this data sharing journey, it's a very important point to raise now. So we have the idea is that you start with a proof of concept. We have some utilities and tools that can really help you, especially if Lydia can share in the chat the test drive utility. And we have also built a workshop which can enable you of how to use this test drive utility, and then can help you in the POC phase, like getting started. How then you can use that utility in your production and do the proof of concept, having the splitting up the workload with the producer and consumer. So if you want to start in this journey, you can reach out to the solution architect team internally, your account teams, and the specialist solution architects can help you in moving to the data sharing architecture with all the tools that we have available.
Yeah, that'd be great. And it leads me on nicely to, if you go to our show notes page, which we'll share our community page in a moment, Lydia will share that. That will have a link to this show. I'll probably do it over the next day or so, where you'll have all of the links in there. You'll also be able to do catch up with this show. You'll also have our LinkedIn references as well. So if you want to come and just message us about any use cases you need, just feel free to reach out over that, over through LinkedIn. So we'll be back next week. So we are building Gen AI powered mentorship matching tool. And I think Lydia's hosting that next week, who's on our chat support today. And we'll be streaming to our normal channels, YouTube and Twitch. So on Twitch at the AWS channel, and on YouTube, it's the AWS events channel. And that is at 5 p.m. CET, 8 a.m. Pacific time, and 11 a.m. Eastern time. And as I said, do visit our community page for show notes on past episodes. So I think we've done something like 90 odd episodes now. We're on season 3. So go and take a look at that. It has our previous shows. There'll be a link to this show over the next couple of days. And thanks for all I've got to say at the end is big thanks to Shrikant and Saman. That was a great show, and I learned quite a bit today, and I think we could have carried on talking for a good while, I think so. And thanks for all of the questions as well. Always great when we get questions coming in. It makes the show a bit more fun. So thanks a lot, everyone.
Thank you.
Cheers.
Thank you very much. Thanks for having us here. Cheers. Bye.
Bye.
Bye.